All right, so today we're going to find the area of the sector. The area of a sector involves knowing what the arc measure is over 360 times the normal formula for a circle. So in this particular situation right here, if we were to find the area of the shaded sector, we would be using arc GH, the measure of arc GH, which is 72, and we would be identifying the radius, which is 15. Once you know radius, and once you know the arc measure, you can find the area of your sector. So the formula is just simply equal to, area is equal to, in this case, 72 over 360 times pi times 15 squared. Now what I'm going to do is, since it's asking me to leave my answer in terms of pi, I'm going to put all of the numbers in the calculator, and I usually save division until last, and then I'm going to stack a pi on the end. All right, so what that means is 72 times 15 squared divided by 360. And I get 45. And then I'm going to slap a pi on the end. That's how it's done. By the way, the whole area of the circle would have just been 15 squared times pi, which is 225 pi. 225 pi, when you put 45 pi over 225 pi, it reduces down to 1/5. So I'm saying that the area of this slice of the pie, of the circle, is 1/5 as much as the whole thing. Well, that's crazy because 72 over 360 is also 1/5. This angle measure over 360 gives you the fractional proportion of what you're looking at in your circle.
Are we going to know how to figure that out?
I mean, I just showed you.
I know, but is that going to be like a question?
No. I mean, I just want you to be able to put it in and get the right answer, but I'm telling you why it works. And it works because this tells me how much of the circle I'm looking at. This is the how much of the circle, and then this formula is just the same as the area of the circle. All right, why don't you try it? You've got a circle of a radius 4 and a 45-degree minor arc. I want you to leave your answer in terms of pi. All right, so hopefully when discovering what the area of the sector is, and this is very important, you have to know how to do the sector stuff. You're going to take the arc measure over 360. In this case, the arc measure is what? By the way, I don't know why they told us that 45 degrees was a minor arc, because the definition of a minor arc is an arc that's less than 180. That's pretty redundant. And then times pi, and then times the radius squared. What was the radius?
4.
So when I put all that into my calculator, I think I get 2 pi, and that's in square inches. Everybody okay with that?
Yes.
Does anybody have any questions about how to find the area of a sector? All right, because now what we're going to do is we're going to be finding areas of shaded regions. So if I want you to find the area of the shaded region in this circle, it's obviously part of the circle, but a fractional part. But how do we know how much fractional part? Well, here's the technique for doing this stuff, and you'll have problems where you have find the area of the region of the segment that intercepts the circle, and they'll want you to find this area right here. Well, first of all, if I do something crazy, like if I fill in this right here, what does the green area look like now?
Sector.
Looks like a sector. Do we know how to find the area of a sector?
Uh-huh.
Yeah, because we just did it. So I'm going to go ahead and put some numbers in here, and I'm going to give you a step-by-step method for solving this. So if I put 100 degrees here, and I tell you that this is a length of 10, we could find the area of the sector. So step 1 is going to be find the area of the sector. Okay, we'll do that in just a second. Now, if I find the area of the sector, that's not really the area of what I want to know. The area of what I want to know actually takes out this portion of the sector. Hey, what shape did I just take out? A triangle. Do we know how to find areas of triangles? You bet your bippy we do. We know how to find all kinds of areas of triangles. So step 2 is find the area of the triangle. By the way, for this particular triangle, what's this side length going to be? Why? Why is it isosceles?
Because both sides are.
Yes, they are. Why?
It's a radius. They're the same distance from the outside.
They're both radii.
Yeah.
Their radius is in the same circle. So it doesn't matter where I draw the radius. It's going to be 10 in this case. So does anybody remember the formula for finding the area of a triangle when you have two angles and two sides and its included angle?
1 base times height.
It's not 1/2 base times height.
Never mind.
It's like 1/2 side.
1/2 side times sine of the angle.
Excellent. So those of you guys that knew that, you are better prepared for the test coming up Friday. Those of you that don't know that, you need to know that. Trust me when I say that you need to know your formulas. Okay, and this one's not on the formula sheet, so this is one you need to know. And then after we find the area of the triangle, step 2, then step 3 is step 1 minus step 2. And that'll leave us with this. So if I start out with this being step 1, and I find this area, and then step 2, I find the area of the triangle, and then in step 3, I subtract off the area of the triangle from that big area, what I'm left with is what I was looking for. All right, so let's work through this mathematically and see what we come out with. So finding the area of the sector is going to be the degree over 360 times pi times radius squared. So that's going to be, the area of the sector is going to be equal to 100 divided by 360 times 10 times 10 times pi. So I get 87.26646. If I round it up to the nearest tenth, I might have a rounding error because I'm looking for accuracy to the nearest tenth. If I round to the nearest hundredth, then that hundredth rounded off. Yeah, so significant figure says I need to take it out 3 decimal places. So 87.266.
So are you getting 3 significant figures from where are you getting?
I'm getting the 3 significant figures from the fact that I want it to be accurate to 1 decimal place, but I want to make sure that I take into account that while if I had a 4 here and a 9 here, then this wouldn't round up to 3. But if I just rounded it up to here, it would round this to 5, and then later I would round this to 3. So I want to go far enough that as I round, it won't affect this number at all. All right, and then finding the area of the side is equal to 1/2 times 10 times 10 times sine 100 degrees. All right, well, 0.5 times 10 times 10 times sine 100 comes out to be 49.240. All right, so now I just put in step 1, which was 87.266, and step 2, which is 49.240, and I subtract, and it looks like 6 minus 0 is 6, 6 minus 4 is 2, 2 minus 2 is 0, and then 87 minus 49 would be 38. So it looks like 38.0 is my rounded off
That's the
answer.
wrong one. You put 4 instead of 1 at 49.2.
Yeah.
You put 4 instead of 1.
This is a 4.
No, 210 equals 240.
Oh, it's 210. So yeah, this would be a 5.
I got 240. I got 1.
You said 2.
Oh, I said 240 and I wrote it down as a 1. Okay. So yeah, I was right. Good eye though. What was written down here was not the same, and you caught that, which is good. This was the mistake, not this one. All right, how do you feel about this? Do you feel pretty confident? Because this is as hard as it gets.
No, that's great. You lost me
All right, where did I lose you?
right after step 1.
Okay, step 2 is find the area of the triangle.
So it's just like a formula thing. Okay. So
Yeah. So it's 10, 10, angle. So it's side times side times sine angle.
Okay. I guess I get that.
All right.
Wait, so is it always an isosceles?
Yeah, because 2 of the sides will always be radii. All
And do we always need to go back to like times 3 after the decimals?
right, let's try one. Try this one. Find the area of the segment of the circle. So what is the area of the shaded segment shown at the right? Round your answer to the nearest tenth. Now, if I told you to round it to the nearest 20th, you'd have to go out 4 decimal places.
So when you're doing this, you multiply pi.
Yeah, I go ahead and multiply pi in. Is everybody with me so far? Did you set up step 1 right? Now this is going to be a great one to illustrate the rounding off thing, because if I were to round off to here and then later round off to here, this would become a 7. But this is not really supposed to be a 7. Everybody with me on step 2?
What if they say down to a math?
So what?
What if they say down to a math instead of down to a sentence?
I don't know.
That's
Because in science there's a bunch of theories, but in math it's all pretty much not theories. It's fact.
You calculating this.
Nope. So now in step 3, I'm just going to subtract the two things, and I should get my answer. So 169.646 minus 140.296 leaves me with 29.35, which would round off to 29.4. Is everybody okay with that? Any questions? All right. Do this one. So the first thing I did was I found the area of the sector. So the area of the sector was equal to, what's that degree angle? 90 over 360 times pi times 4 squared. So that's going to be 4 pi, which when I plug that in is 12.566. All right? And then the area of the triangle is equal to 1/2 base times height, or 1/2 times side times sine 90. I'll do it that way since that's the way I showed you. Sine 90 is just 1. So that's why it looks like the base times height times 1/2 formula. So that's just 8. And so it's 12.6 when you round off. Not 12.6. Holy cow. 4.6. I need to learn the maths. And what's the units? Square meters. Any questions about that? All right, your homework assignment for tonight.